Our next speaker will be Alexandra Dmitrienko, and she'll be talking about Phonion, practical protection of metadata in telephony networks.
Okay, do you hear me well? Okay, so this is work, collaborative work between several institutions. Here, I would like to talk about Phonion, the framework which allows users to communicate in an anonymous way using standard regular telephony networks. So this picture shows typical telephony bill which we get from telephony network providers, and those bills typically include privacy-sensitive data, which are called call detailed records, and they include such information like, unfortunately, pointer. Here it works. So it includes the date when the call was made, the starting date of the call, the duration, and the destination. And of course, this type of data may introduce large interest for different types of adversaries. So who could be our adversary in this case? The adversaries have wide range. Those could be jealous supposers and private detectives. They hire companies who pay employers cell phones. They want to maybe see if you use your phone also for private use. There are rogue employers of cellular network providers. Maybe they sell the data to criminals for benefits. People involved in messy divorces and lawsuits, they may look for dirt. Political campaigns, digging for scandals. And maybe last example, most relevant for this community, authorities may be tracking journalists who would like to leak information or maybe tracking informants who leak information to journalists to avoid publicity. So what about powerful adversaries? There was a statement made by former chief of CIA and NSA who said that we kill people based on metadata, and this basically what he wanted to say here, that to get very important information, it is not necessarily to look into the content of the call, but it is sufficient to look who communicated with whom and in which time. Generally, attackers can be classified in 4 categories. We propose 4 classes of attackers. The first class is associates. This is a less powerful attacker, such as employee or private person. Network providers who can directly look into those records. We have law enforcement agencies which are bound by jurisdictions, for example, by boundaries of certain countries, and intelligence agencies, which we assume have unlimited power, but in practice, to perform very powerful attacks, even intelligent agencies have to spend a lot of resources. So the research question we would like to answer in our work is, can we protect user privacy even in presence of metadata collection, because we can't really influence the way the data is collected, but we still want to communicate in a privacy-preserving manner. And we designed the Phonion system, which provides such an option. And I would like to, in the rest of my talk, I would like to present it to you. So we wanted to fulfill certain functional objectives. The first objective is offline calls, because one can think of, we could use voice over IP, over Tor, and achieve something similar, but we don't always want to use voice over IP. Even we use often Skype and WhatsApp, but we still quite often use also regular phone calls, because the possibility to use it in offline mode. We want to achieve high quality of service because regular telephony networks typically provide better quality than voice over IP. And we want to also to be compatible with standard voice telephony technology. And this has something to do with user habits, because if, for example, a journalist has informant who get used to telephony technology, who doesn't want to use any voice over IP client, he doesn't have actually a choice. He cannot push the source to switch the technology. So in a high level, Phonion uses ideas which are similar to Tor. So when we have a call established between Bob and Alice, we have here two providers, Bob's provider and Alice's provider. Both providers keep call records, so each of them can see that those two communicated. But once we insert the forwarding node in between, then the Bob's provider sees the number of the forwarding node as destination, and Alice provider sees the phone number of the forwarding node as the source of the call, so they don't know. Compromised provider cannot see the fact that those two parties communicated. To make system even stronger, the system supports up to 3 forwarding nodes, and in this case, we can tolerate even both compromised providers and certain nodes in the system. Forwarding nodes can be compromised as well. So for the security, it is sufficient that at least one forwarding node in the established circuit is non-malicious. And to get stronger security guarantees, for example, guarantees against adversaries who are limited by jurisdiction boundaries, we place forwarding nodes in different places, for example, in different countries, and this makes the task for the adversary even harder. Phonion infrastructure includes several components. Those are forwarding nodes I was talking about. They perform actual call forwarding. Then we have a component which we call broker, which is similar to distributed directory authority in Tor. This component includes information about all the relay nodes available in the network. And we have a client-side software which can communicate with Phonion infrastructure and, for example, establish the call circuit. So Phonion operates in two modes. In the first operational mode, the user first has to establish call circuit before it can be used. Assume Alice wants to get the call from Bob. She would first create the circuit, and in this procedure, the client first would request a list of available nodes from the broker. Alice would have to select the nodes, forwarding nodes from that list, and then the client software would configure the forwarding rules on those nodes. And this phase, the communication is performed using internet connection, so we need internet connection in this phase. And we protect communication using Tor network so that even if the adversary observes this phase, he cannot actually see if the client communicated with Phonion infrastructure. In the second phase, Alice can share the Phonion number she received after circuit establishment. She can share this number with another party, for example, with Bob, and then Bob can use any standard phone device, even very old rotary phone, to dial the number, and the call will be forwarded through the relay nodes and land on the Alice phone. And although along the lines all the internet or all the telecommunication providers collect metadata, they won't be able to figure out that Bob and Alice communicated unless they basically can collect all of them along the route. So we implemented the system. Basically, we built the system, and we have working prototype. For the forwarding nodes, we use different technologies. Asterisk, which provides the ways to establish forwarding nodes which can forward calls from landlines to cellular network, also voice over IP. We also used cloud-based services like Twilio and Google Voice. For the broker, first we implemented solution using Python and Flask web development framework, but as a next generation now we are looking how to implement this functionality using blockchains. In this way we want to reduce trust assumptions put on this component. We have the client software implemented for Android, and we also put Bitcoin payments on top of it because phone calls, they are not always for free, so sometimes the client needs to pay for the service he's going to use. So we performed evaluation of the system, and in particular, privacy evaluation includes analysis of tracing attacks and timing attacks. There are more details in the paper. Here I would like to point out that the tracing attacks can be performed by the intelligence service because agencies, because this powerful adversary, we assume, can compromise everything. So once intelligence services can get all the records from all telephony providers, they would be able to trace the call. But we are doing well against other three types of the adversaries. And another type of attacks is timing attacks. In this type of the attack, the adversary tries to compromise. For example, here he monitors Bob and Alice, and he would like to know if those two talk to each other. So he's trying to see if they talked at the same time. And in this manner, then anonymity set gets reduced, so the attacker might be more successful in that. And this graph shows our results for timing attacks. So here on X-age, we have the number of users. This is the total number of users in Phonion network. And in Y-age, we have the probability for the adversary to figure out that Alice and Bob communicated. And this graph also depends on the parameter Q, which represents the probability for any pair of Phonion user to use the compromised telephony network operators from which the attacker get the record. Obviously, the more users are communicating using this compromised node, the larger the anonymity set for the attacker. So the larger Q is, it means the harder for the attacker is to figure out if two users talk to each other. So we also performed evaluation regarding to latency. So here there are test results for 5 circuits established through Phonion network, and results are compared with circuit established Tor with the results obtained by using voice over IP over Tor. So here we see that the latency is much better for Phonion network compared to Tor, which is expected. And we also estimated voice quality using industrial standard PSQ. This standard records the signals received and compares it to the reference values, and the result is scheduled from 0 to 4, and the 4 is considered the best result. So for the same circuits, we get, as we can see here, the results are higher than 3 for Phonion, and between 2.5 and 3 for Tor circuits, which indicates that we can get much better quality for voice communication. So to conclude, we built a system which we call Phonion, and it provides the means for two users to communicate using standard telephonic communication technology. The phone calls can be done with high quality. They don't require online connection, and the system provides anonymity against first three classes of the adversaries, like associates, telephony network providers, and law enforcement agencies, and even complicates analysis for intelligence agencies. As a future work, we consider, as I mentioned already, this blockchain-based broker instantiation based on Ethereum smart contract. And second, we would like to automate the step of selection of routes, because at the moment, as it is implemented, the user have to basically manually pick up the routing nodes, but probably this is not the best approach, given that the number of relay nodes could be pretty large. So thank you for your attention, and I would like to take your questions.